Good afternoon to all. Welcome back to our course on the C programming language. In today's session, we are going to discuss about the unions part 3, where I'll be discussing about the concept how we can access the members of the union. This part is almost similar to that of the structures. If you consider the concepts related to the unions, they are almost similar to that of structures. In the similar fashion, accessing members of the union is similar to that of accessing members of the structure. So as we have discussed in the earlier sessions of accessing the members of the structure, there are two different operators that can be used to access the members of the union. The first one is the dot operator, and the second one we call it as the arrow operator. When we are going to use this dot operator and when we are going to use this arrow operator is, this dot operator is used when you want to access the members of the union using normal union variables. Normal variables of union. And this arrow operator is going to be used when you want to access the members of the union with the help of pointer variables. So you need to declare a pointer variable to the union, and by using this arrow operator you can access the members of the union. At present point of time, let us postpone our discussion of this arrow operator. Why? Because we don't have any discussions on the pointers concept. So once we complete the concept of pointers, we'll come back again and discuss how we can access the members of the union using this arrow operator and pointer variables. So let us confine our today's session for the first point, that is how we are going to access the members of the union using dot operator and normal variables of the union. So let me write a simple program to explain how we can access the members of this union using dot operator. So I start my program with the preprocessor directives, that is hash include stdio.h, and then I start my main function with the return type as integer. And now I would like to define a union. See here, this union is defined as the local to the main function. So you can make use of this union only in this main function. You cannot declare variables for this student data type in other functions. So this is the important point you should understand. You can also declare this union outside of this main function at this particular point, where it is called as the global definition of the union. Therefore, when you define the union globally, that particular union will be accessible by all the functions in the program. So any function in the program, they can create the variables of the union and they can make use of it. But in this example, I'm just confining myself to a local union definition. So I'm restricting myself to declare the variables of the union in this main function only. That important point you should understand here. So I'm again continuing with the same union example what we have discussed in the previous sessions. So we have registration number, we have gender, and finally let me take the double CGPA like this. Now this is union definition, and remember that no memory will be allocated at this point. And I would like to declare a variable for this union student. So what I will do is I will create a variable called S1, and that S1 belongs to data type union student. Right. Now my concept is I would like to access the members of this union using this variable. So as we have discussed in structures, the syntax for accessing the members of the union with the help of this variables is nothing but it goes like this. First we have to write the variable name, whatever structure variable you declare, and after that you use this dot operator, and then you have to write the name of the member. So this is a generalized syntax to access the members of either the structure or the union. So it is variable name, which is nothing but the variable of type struct or variable of type union, whatever it may be. And here we are making use of the dot operator, and then we have this name of the member. So if I want to access this registration number by making use of this S1, I can access it like S1 dot registration number. If I want to access the member gender of S1, I can access it by S1 dot gender. If I want to access CGPA member, then I can access it by using the syntax like S1 dot CGPA. So this is the overall overview of how we can access the members of the structure. But in the previous session, while we are discussing the memory allocated for the union, it is equal to the memory that is allocated for the maximum sized member. Here in this student data type, what I have defined here, the CGPA is having the maximum size, therefore 8 bytes of memory will be allocated for S1. And remember that these 8 bytes of memory will be utilized by all the members. So they are sharing this common 8 bytes. They are sharing this memory locations, 8 bytes of memory locations. So when you want to store registration number, that will be stored in this 8 bytes only. When you want to store the gender, that will be stored in these 8 bytes only. When you want to store this double CGPA value, it will be stored in this 8 bytes only. That means total 8 bytes will be allocated, but when you want to store the registration number, the first 4 bytes of this 8 bytes will be utilized by registration number. And if you want to store the gender, the 1 byte of these 8 bytes out of 8 bytes will be utilized by this gender. Similarly, when you want to store CGPA, it will utilize all the full 8 bytes of memory. So this is how it is going to utilize the same memory locations or reuse the same memory locations. Why? Because this is a shared memory, very important concept. This is a shared memory. So every member of the union will be sharing this memory, right? And let us see how we can assign a value to this S1, registration number of S1. So let me say I can use the variable name S1 dot, the member name is registration number. Let me say that I assign a value of 501 here. Here I am just hard coding the things. That means I am just assigning the fixed values to this registration number or gender or CGPA, whatever it may be. So when the compiler comes across this statement, this 501 will be stored in the 8 bytes. So here it will store 501. The first 4 bytes will be utilized to store 501. Assume that when I want to assign some value to the gender, so I can access it by the variable name, that is S1 dot member name, which is gender. Since it is character, I assign it with let me say it as male. Since it is a character, I just use this single quotations. So at this point, when the compiler comes across this point or at this statement, what the compiler will do is it will access the gender of S1 and it is going to assign a value of M, which represents the male, to this gender of S1. So we know that the same memory location will be utilized by the unions, right? So when you want to store this M in this 501, what happens is the previous contents where I have stored this 501 will be erased, and whatever value that I am going to store here, that is M, it will be stored inside this 8 bytes itself. It will be stored inside this 8 bytes itself. So it will overwrite the value of 501 to M. Similarly, when I write s1.cgpa, I access the cgpa by using s1 and dot operator, and let me write it as 9.7. So this value has to be stored inside these 8 bytes only. So whatever value we have in the previous statement, that is M, they will be overwritten and it will store the value of 9.7 like this. So always remember that when you are making use of the unions, you make sure that you access the members of the unions one at a time. Only one member can be accessed at a time. Very important point. But when you consider the structures where each and every member of the structure will have his own memory, so you can access all the members at a time. So structures work on the basis of all at a time, and unions, they work on the basis of accessing one member at a time. This important point you should understand. So finally, whatever value we have, that is 9.7, is being stored inside these 8 bytes. For example, if I want to print the value of CGPA, so I use the standard output function. From here to here I am writing, I am continuing here. So printf, I want to access the double function like this. So I can put as s1.cgpa. So this will print 9.7. The value that we get here will be perfect. But when you try to print the value of CGPA, gender, which is C, I write like this. So this will give some garbage value, or in some compilers you may get some error, or you may get some warning, right? The reason why this s1.gender is going to give some garbage value or a warning is, we know that the last value that I have stored in these 8 bytes of memory is CGPA, which is 9.7. So the previous value M is overwritten, so you don't have the power to access this gender. Similarly, when I try to print this registration number by making use of s1.regd number, this is also a garbage value. This will be also a garbage value. The reason is because the registration number has been overwritten by gender and gender has been overwritten by CGP. So always remember one important point, that unions allow the programmers to access only one member at a time, and the latest value that you are going to store will be the value that is stored inside the union. The latest value in this example is the CGPA is equal 9.7. This is the value I have stored. So when you print this value, you will get the correct value, and when you try to print the remaining values, you will get some warnings or garbage values. So this is a very important point. You should understand that you can access only one member at a time in the unions. So that is all about the accessing the members of the union. And as I told that the usage of arrow operator using the pointer variables of the union will be discussed after we discuss the concept of pointers. Before wrapping the session, let us have a quick discussion on what we have discussed under today's session. We have started our discussion on the accessing members of the union. We can do it using two ways, that is the dot operator when we have the normal variables of the union, and the second one is the arrow operator when we have the pointer variables of the union. And the syntax for accessing the members of the union using the variable common variable is the variable name, which is nothing but the union variable name dot member name. So we have I have shown one programming example of how we can access the members of the union. In this example, I have clearly defined a union which is of type a union named student, and it is local. Therefore, I can declare only one local variable. I can declare only local variables, not one local variable. You can declare any number of local variables, but they should be local to the main itself. And one important point, very important point we have discussed here is the structures, the union variables or the members of the union can be accessed only one at a time. When you try to assign more and more values to the members of the union in a consecutive statements, the latest value what you have updated will be the value that will be stored inside the memory location of the union. So here in this example, the CGPA is the latest value. Therefore, when you try to print the CGPA, it will print correctly, and when you try to print the other members of the union, you will get some garbage values or some other warnings like that. So this is how the accessing the members of the union using normal variables will work. Everything has been explained with a programming example also. This is all about the concept of accessing members of the union. Thank you one and all for joining the session.